When a port goes through the normal STP blocking to forwarding transition, we're looking at a 50-second delay before the port can start beginning to forward frames, because we're looking at 20 seconds of max age while it ages out a superior BPDU that is saved. Then we've got the listening stage, then we've got the learning stage. Each one of those is 15 seconds. So it's almost a minute. Big deal, right? Yeah, right, from one networker to another. Man, that almost minute can seem like hours at times. Now, we know that configuring a port with port fast is one way to skip a little bit of that delay, but as you saw in the last video, we are advised over and over and over by CISCO not to use port fast unless it's on a port where a single host device is found. What if the device off that port is another switch? I'm sure you were asking that during the last video when we're getting all of these warnings about using port fast on a port leading to a switch. Well, that's where uplink fast can come in handy, and here's a walkthrough to show you how. Switch 3 has two paths to the root, and assuming all port speeds are the same, the shortest path would be the one that S3 uses to reach the root, which would be anyway the shortest physical path, that being out the forwarding port that goes directly to switch 1. Now, STP only needs to block one of our 6 ports in order to prevent switching loops. We saw that in an earlier walkthrough, we're seeing it here, and that's good. But if the open path between switch 1 and switch 3 goes down, there will be approximately a 50-second delay before that blocked port is open, and that's bad. Well, with uplink fast, the ports that switch 3 could use to reach the root are collectively referred to as an uplink group. Now, this uplink group concept, it includes ports in blocking and forwarding mode, and in this case, the 2 ports that you're seeing shown on R3, the one that goes straight to switch 1 is in forwarding, the one that goes off to switch 2 is in blocking. That's our uplink group. Well, if the forwarding port in the uplink group goes down, the link goes down, something happens to the port, whatever, another port in the uplink group is going to be transitioned almost immediately from blocking to forwarding. Now, naturally, as you'd expect, if there are multiple ports to choose from in the uplink group, if we had a couple of backup ports here, then the port with the lowest cost to the root would be chosen. Certainly second nature to us by now. But here, this is what we have. And switch 3's link to switch 2 with uplink fast enabled is going to go straight from blocking to forwarding. It's going to skip the listening and learning stages. Now, when I said almost immediately a moment ago, I've seen once or twice over the years some CISCO documentation mentioning that it's an immediate cutover. And the first time I saw it in action, I was like, well, it doesn't look immediate, it must not be working. And then like 2 seconds later, everything was fine. So you have to give it a couple of seconds, like 1 to 3 seconds. Now, CISCO strongly recommends uplink fast not be used on distribution and core layer switches. Remember back in your CCNA days when you learned that 3-layer model, access, core, distribution, not in that order, access, distribution, of course, going to the center, and we never really used it. We spent really all of our time with the OSI model, and that was enough, and the TCP IP model. But in this course, we're using it a lot. And CISCO comes back to that model over and over. So again, they're saying don't use it on distribution and core layer switches. I'm going to show you one reason why you wouldn't do that in just a moment. Uplink fast is different, though, from almost every other service we're seeing in this particular section because we can enable it globally and for all VLANs residing on the switch, and that's it. It's all or nothing with uplink fast. You can't run it on a per port basis. You can't run it on a per VLAN basis. It's all or nothing. Now what happens is the original root port on the uplink enabled switch, this is the great part, when that port comes up again, you and I as the network admins, we really don't have to do anything for that port to become the root port again. Because once it detects the original primary path to the root is again available, it cuts over and it cuts back to the original root port. That also doesn't take place immediately. By default, the switch is going to wait 2 times your forward delay value plus another 5 seconds before the primary root port again enters the forwarding state. And that, of course, is to prevent switching loops. Now, there are 2 immediate actions that uplink fast is going to take, and you need to be aware of these. Going to do them on the live equipment, and this will also show you why you only want to use uplink fast on your access layer switches. So let's take a look at the command. And also you see, I want to go ahead just verify, show spanning VLAN 1, And for this particular lab, this bridge is the root for VLAN 1, and it's got a couple of interfaces, 1 and 3 going off to hosts, and 10 and 12 are our trunks. So let's see, what do we got? Let's run uplink fast. Everything else looks normal so far. Let's do a spanning, and there's uplink fast. And there's one option, max update rate. And then we could just enter it the way it is. So that's exactly what we're going to do. And now let's run show spanning VLAN again one more time. And things have changed. I believe we're about to see that little phrase disappear too. It still says this bridge is the root. We're going to give that a second because I don't think that's going to be true anymore. You see a couple of big changes here. The first one being that the priority has skyrocketed to 49,153. You also see that our root ports are all much more expensive than they were a few moments ago. It looks like 3,000 has been added to every single one of them. And that's exactly what has happened. Try that again. Under cost, there you go, where we had 100, 119, 19. Now we have 3,100, 3,100, 3,019, and 3,019. You can see now that the phrase "this bridge is the root" is now gone. So this bridge is no longer the root. It was before we ran uplink fast. So, and you can also see uplink fast enabled under the bridge ID information. So what happened here? Well, we know what happened, but that goes along with starting uplink fast, and here's why. The first thing that's going to happen, the switch priority is going to zoom up to 49,152. And you take your system ID extension, the VLAN number, add it to that, and that's your final priority. So as soon as you see 49,152 plus your VLAN number, you know uplink fast is running on that switch. What that does, it effectively prevents the switch from becoming the root, really in most probabilities, unless all of your other switches have gone down, which of course means you have much bigger problems to worry about than uplink fast. So this is why you don't just suddenly go to your core or distribution where your roots are liable to be and just start enabling uplink fast. So that's one reason. The other one we saw was the port cost soaring. And the STP port cost is going to be increased by 3,000, making it unlikely that that switch is going to be used to reach the root switch by any downstream switches. Now we have a 3-switch network here in our lab, so that's not reflected on downstream switches, but you did see the port cost zoom up. So you're really saying when you enable uplink fast on a switch, what you're saying is, I don't want this to be the root, the priority is going to go up, and I don't really want it to be used to reach the root by downstream switches. Now uplink fast works really well, and on occasion it can work a little too well, and that's where that one option comes in. Let's revisit this our original network, and I've added a couple of hosts to illustrate this concept. Now, frames from host A to host B are currently going to go through switch 2, then switch 1, then switch 3. So we know, even though we weren't given the port speeds, that's why you always want to check your port speeds. The link between 2 and 3 must be pretty slow in this example. Now, when the link between 3 and 1 goes down, that path would no longer be valid, but the now invalid entry to get frames to host B would still be in switch 2's MAC address table. What we want to do is update the other switches' MAC address tables as quickly as possible. And that's where our single uplink fast option comes into play, and that is spanning uplink fast, and the option is max update rate. And this is exactly what we saw in the live equipment, rate at which station address updates are sent. Well, the cutover to the backup path is fast, and it's so fast that, again, the MAC address tables of other switches in the network may be out of date for a few seconds after the cutover. And to avoid that, in our example, what we would want to have happen, what is going to happen in the example, is that switch 3 is going to send dummy multicast frames to switch 2. Now, the destination address, I think that's worth knowing, it's 0100 0CCD CDCD. Well, that's the destination address for the dummy multicast frames. The source address, there's the problem, perhaps. We're going to send these frames for every single MAC address entry in switch 3's table. And by doing that, what we're doing is quickly updating, first off, switch 2's MAC address table and then that of other switches. But the thing is, the MAC address entry there might be small, the overall table might be small or it might be large. And again, this is what happens. That flooding is going to come. We're flooding dummy multicast packets to 0100, the destination 0100, 0CCD, CD. The source, each entry, and the local MAC address table. So again, that quickly updates switch 2, but if you're configuring this and you think, switch 3's MAC address table is just huge, you may want to adjust that maximum update rate, which is 150 packets per second. And you can also disable those settings if you want to, or the sending of those frames by setting it to 0. I've never seen a good reason to do that. It's actually a good idea to flood those frames out and get those updates out there as quickly as we can. And you can also verify whether you have Uplink Fast enabled or not, and what your station update rate is by the command show spanning uplink fast. So again, that's it for uplink fast. It's a good idea, certainly to realize how this compares and some of the rules that go with it that don't necessarily go with backbone fast. They sound kind of familiar, uplink fast, backbone fast. They're definitely not the same thing, and they definitely have some different rules. We're going to see that in a future video in this section, and speaking of that, I'll see you on the very next one.